Hello everyone and welcome back to my new video. This is part 2 of factorization. The other video was part 1. We're going to continue by introducing factorization of binomials. So as I said in the previous video, I'm going to talk about 3 types: difference of 2 cubes, difference of 2 squares, and the sum of 2 cubes. You might be faced with a binomial that does not need any fancy shortcut or anything, such as suppose you're faced with 3a cubed b squared minus 6ab to the power 4. In this case, you'll just use complete factorization and your common factor would be 3ab squared. Your quotient would be therefore a squared minus 2b squared. However, sometimes you might be faced with more fancy binomials in which, as I said, it's better if you use certain shortcuts. So suppose you're faced with x squared minus 9. Okay, so this is a difference of 2 squares. Oops. Let's just consider first any number. So suppose you're faced with a squared minus b squared. The rule says that to factorize this, you need to, first of all, find the square root of the first term, a, minus the square root of the second term, b, times the square root of the first term, again a, plus the square root of the second term, b. So this is how you factorize it, how you turn it from a difference to a product. Likewise, if you're faced with this, you can turn it into that. So it's these things work vice versa. It's not just, so you would expand the brackets, but do not expand it multiplying each term by each, getting those 4 terms you would get otherwise. Just turn it into a squared minus b squared. So when you're faced with something that has the same base, the same numbers, but different sign, so the opposite sign, you would turn it into this. Okay, so coming back to our x squared minus 9, this would be then x minus 3 times x plus 3. The order of the brackets do not matter, so you might have x plus 3 times x minus 3, nothing changes. Okay, so that's for difference of 2 squares. Now getting on with the difference of 2 cubes. Suppose you're faced with x cubed minus 8. Again, if we consider any number, not particularly these two, so we consider a cubed minus b cubed, the rule says, careful with that, is the cubic root of the first term, a, minus, because there's a minus here, the cubic root of this second term, b, times what we call the false square. Why do we say it's a false square? Well, because suppose you have the false square of this bracket, by the way. So suppose you have a minus b squared. If you had this, it would turn out to be a squared minus 2ab plus b squared, isn't it? Well, a false square though does not have this 2, and the sign here is the opposite, so it's a plus. If here is a minus, here is a plus. Therefore, our full square would be a squared minus plus ab plus b squared. Therefore, our full square of this a minus b would be a squared plus ab plus b squared. This is how you factorize a difference of 2 cubes. Coming back to our example, then for this you would have x minus 2 times x squared plus 2x plus 4. What happens then with the sum of two cubes? It's really similar. The only thing that changes is actually just the signs. So suppose we have a cubed plus b cubed. You would get a plus b, so it's still the cubic root of a plus the cubic root of b, times the false square in this case as well. And because we have a plus here, it would be a squared. I'll just delete that because it's confusing. It would be a squared minus ab plus b squared. Okay, so what changes is just the sign on here because we have a plus, but it's still the full square and it's still the cubic root of a and plus the cubic root of b. So this is the add up of two cubes. Let's get on with the example. The example does not just include the add up of two cubes, but also either the difference of two cubes or difference of two squares. That's why I wanted to leave it at the end. So suppose you have x to the power of 6 minus y to the power of 6. There's two ways to do this. The first way is to consider that at first as a difference of two squares. Or to consider it at first as a difference of two cubes, because it's both actually. So let's go on with the difference of two squares. If it's a difference of two squares, this would be x to the power of 3 x cubed minus y cubed times x cubed plus y cubed. And look at that, we have both a sum of two cubes and a difference of two cubes. So how would you do this? Let's zoom in, so this would be then x minus y times x squared minus plus 2. This would be then x minus y times x cubed plus xy minus y squared. And this one would be x plus y times x squared plus minus xy plus y squared. Why would you have this whole thing? So you literally have 1, 2, 3, 4 terms multiplied together. It's huge. Why would you have this? Well, suppose you are doing fractional, you're working with a fractional expression and you need to divide and cancel out certain things and divide terms by each other. This would allow you to do so. This would not. Okay, and of course if you're faced with this one here, so if you're faced with this, you would know that this is the difference of two cubed and this is the add up of two cubes. So you need to be careful with that and think a bit out of the box. Let's start then with the difference of two cubes. So x to the power of 6 minus y to the power of 6 would be x squared minus y squared times the false product of that, which is x to the power of 4 plus x squared y squared plus y to the power of 4. This here is a difference of two squares, so you'd end up with x minus y times x plus y times this whole thing here then. And this is how you would solve, these are the two ways in which you could possibly solve this binomial here. I hope it helped. If you have any question, please pop up in the comments and let me know any questions you have.